Hello viewers, welcome back to another section of our applied electricity tutorial. In this video, we have a simple circuit here and you have to find the effective resistance across the terminals A and B. So to do that, first of all, we have to work away from these terminals. So we have to start from this side, then we push it towards this side. We don't start from here, then we move here. Then number two, we take two resistors at a time whenever you are considering the simplification process. So if I want to start from here, I'll take this and this, but I don't take three. So let's start from the farthest end, which is 6 and 4. So you ask yourself, these 6 and 4, are they in series or in parallel? Then you trace it here, you realize that there is a node here, then there is another node here, meaning they can't be in series, so they have to be in parallel. Then you traverse through them if they are the only two elements in the loop, hence it qualifies that our 4 ohm is parallel to our 6 ohm. For that reason, we simplify these two and this becomes 4 times 6 over 4 plus 6, and that is giving us 24 all over 10, which is also equal to 2.4. So once you get this, the next thing to do is to simplify. Now we have been able to combine here and here, so you redraw the circuit and make sure that you combine the parts we have found the total resistance. So you start again, then you draw the other parts of the circuit, then you have this side. So you realize that this place and this place will be together as a single branch here because we have found the total resistance to be 2.4, right? Then this remains 3, then this remains 4 ohm, then here is 1, then this place comes here as this. So here is A, then here is B. So at this point, we have our 3 ohm here, we have 2.4 ohm, which is the farthest part of our loop. So when you consider these two again, you realize that there is no node here between the two resistors, and hence the same current will pass through when it starts from here. So this is a whole branch in which there is no node in between the two resistors, or current will not split in between the two resistors, hence they are in series. So you realize that you find the series resistance of 3 ohm plus 2.4 ohm, and that one will combine and you get a more simplified circuit as our A, then our one will come here, and the whole of this will be a single branch of 5.4 ohms from this simplification. Then this one will join this side to this, then we move to this to our B. So once you have this, you draw our, we have 3 ohm here, sorry, this and this is 5.4 ohms, then this place remains 4 ohms, that is this place was 1 ohm, so our 1 ohm, then here was 3.3 ohm on the question, so here too is 3.3 ohm, right? So still working on the farthest part of the circuit, you realize that our 4 and 5.4 ohm are in parallel because when I take this branch, this and this, there is a node here and the current will split to pass through them, hence they are in parallel. And when I traverse through them to this side, I wouldn't meet any other elements in the circuit. For that reason, these two are in parallel. So let's solve our parallel combination. So 4 ohm is parallel to 5.4 ohm. let's see. So we are going to get 4 times 5.4 over 4 plus 5.4. So what will be the answer for this part? So 4 times 5.4 over 4 plus 5.4. That is giving us 108 over 47. So once you get this, then we move on. So you realize that we have combined this part and this part and we had this. So we keep on coming forward. So you will still redraw. Here's our A, and this is it. Then you have this side. Now you have only single branch representing the 4 and the 5 here. Then you come back here, whilst we still have our 3.3 here. Then you have our 1 ohm here. Then our 108 over 47. Which you realize that this and this are in series now, right? So you can clearly see that one and this one are in series. For that reason, we simply add them, then we continue to redraw the circuit. So you have 1 plus 108 over 47. And what are we getting for this? So 1 plus 108 over 47. And that is 155 over 47. Then take notes. Please don't be converting it to decimals as you are solving, otherwise you may get an inaccurate answer. So always leave it in an improper fraction. Then upon your final simplification, you convert them to decimals. So at this point, when I redraw the circuit, I'll get my A coming down. So I'll get my A coming down to the 3.3. Then my B, this side and this side will combine to be 155 on 47. Then we find the effective resistance here, where here is B and here is A. So at this point, this and this are now in parallel. So you get 3.3 times 155 over 47 all over 3.3 plus 155 over 47. So what are you getting from this? So let's see. 3.3 times answer over 3.3 plus. So the solution for this then becomes 1.65 ohms. That is the total resistance found between the terminals A and B of the circuit given in the question. So a review of what we've done is we are given A and B as the terminals here to find the effective resistance. So from here we take resistors farther away from the terminals, then we draw close to it. So we take first 2, then we simplify to get 2.4, then we read through the circuit to get this way. Then this and this was in series, so we got 5.4 for that. Then we still continue to redraw the circuit Then 5.4 was also in parallel with this, and the simplification continued. Then we came to get the final simplification as 1.65 ohms. So this is how it is done. Thank you for watching this video and joining this section. Please don't forget to like, subscribe, and also share.